Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 14.2, Problem 8. This is Section 14.2, Problem number 8. It says Manny's brother, who is also named Manny, suggested that Manny use his existing building for his car dealership as one of the four sides of the enclosed area described in problem 7. So instead of letting the fence make up all four sides of the enclosed area, there's a building anyway. Use that as one of the four sides and you get more benefit from your fence. It's a good idea. So A says, what dimensions will produce the largest possible area with Manny's 200 yards of fence? If you remember from the previous problem, he has 200 yards. And now instead of making four sides for his rectangle, he only has to use 3 if he puts the fence up against his existing building. So it's a pretty similar problem. We want to have a function for area, which is basically length times width. And we want to take the derivative of that function, set it equal to 0, solve the unknown. And the problem is that we have two variables. We can't go through that process of take the derivative, set it equal to 0, solve for the unknown until we have this as one variable. So there's 200 yards altogether to go around this area where one side is the building. So what you need to remember, you have two sides that are y, one on the left, one on the right. So 2y plus x, the distance that's going to run parallel to the building, is going to add up to 200, the total amount of fence. So now you just solve for one in terms of the other. It's still, you can do either one. It's still easy to solve for x. So let me go x equals 200 minus 2y. And instead of length times width, since my diagram here is x times y, the length is x times the width is y. So the variables will agree. So now that I know x is 200 minus 2y, let me substitute that in for x. So area equals, instead of x times y, 200 minus 2y, because that's equal to x. So that is x, and then times y on the end. So now there's a function for area expressed in terms of only one variable, and I can clean it up a little bit by clearing the parentheses. So area equals, so y times 200 will be 200y, and then y minus times minus 2y will be minus 2y squared. So now there's the function. What we have to do is set it equal to 0, take the derivative first, then set it equal to 0 and solve for y. So if I set this equal to 0, I'll do 200. Oh, I have to do the derivative first. Well, the derivative I should write as a prime equals the 200y. We'll just make 200. Again, when you have a variable to the first power, the derivative is just the number in front, in this case 200. The minus 2y squared will be minus 4y to the first. And again, what's happening is the exponent of 2 comes down times the number in front, which is minus 2. 2 times minus 2 is minus 4. Y to the 1 less power, the second power drops down to a first power. Now I set it equal to 0. 200 minus 4y equals 0. Solve that. So bring the 4y over. I'm going to go 200 equals 4y. So the 4y was negative when it was on the left side of the equal sign. When it comes to the right, it becomes positive. Divide out the 4, and you'll get 50 equals y. So y is the left and right side. 50 on the left, 50 on the right. And if there's 200 feet of fence altogether, and you've used 50 on the left, 50 on the right, there's going to be 100 yards of fence that runs parallel to the building. So part A, what dimensions will produce the most area? Well, 50 on each side and 100 across the length will produce the most area. And then B says, what is the largest possible area that Manny can enclose with his 200 yards of fence? So again, if we're going length times width, or x times y, area equals length times width, which we write in this particular problem as x times y. So that would be the x is 100 times the y is 50. And if you multiply that out, 100 times 50 is 5,000. And your units of measure would be square yards. So 5,000 square yards is the most you can enclose.